In this lecture, we will study the discovery of heliocentrism, the astronomical model in which the Earth and planets orbit around the Sun, at the center of the universe. Historically, heliocentrism was opposed to geocentrism, which placed the Earth at the center. We will go through the story of mankind's struggles for discovery of truth. The beginning, a world in darkness. For centuries, humanity gazed up at the heavens, convinced that Earth sat motionless at the heart of the universe. Great civilizations, Babylonians, Egyptians, Greeks, looked to the stars for guidance, their myths shaping a cosmos where the sun and planets danced around our world. Aristotle, the great philosopher, and later Ptolemy, the esteemed mathematician, constructed an elegant, albeit flawed model, the geocentric universe. In this vision, Earth was the immovable centerpiece, and celestial bodies moved in complex loops, called epicycles, to explain their erratic motion. This belief held firm, unchallenged, for over 1,000 years. A flicker of doubt. But even the mightiest of ideas can be questioned. In the distant observatories of the Islamic Golden Age, scholars such as Al-Tusi and Al-Shatir peered into the night sky, their calculations whispering inconsistencies in the Ptolemaic model. Meanwhile, in Renaissance Europe, a newfound thirst for knowledge was brewing. The stars no longer seemed content to obey the old cosmic order, and cracks began to form in the ancient model of the cosmos. A rebel named Copernicus. Amid this atmosphere of change, a quiet but revolutionary figure emerged. Nicholas Copernicus. Working in secret, he meticulously studied planetary movements, daring to entertain an idea that had been long dismissed. In 1543, he published a radical truth. The Sun, not Earth, was the center of the universe. The planets, including Earth, circled the Sun in grand cosmic arcs. But his ideas were dangerous. Questioning the established order could mean persecution. Fearing backlash from religious authorities, Copernicus delayed publishing his work until the end of his life, escaping direct punishment, but leaving a legacy that would shake the foundations of science. The Watcher of the Heavens. Almost a century later, a man with a telescope stood under the night sky, ready to challenge the heavens themselves. Galileo Galilei, armed with a new invention, turned his gaze upon Jupiter and made a shocking discovery. 4 tiny moons orbited the giant planet, proving that not everything revolved around Earth. He studied Venus and saw its phases, further supporting Copernicus's vision. But such revelations came at a cost. The Catholic Church, fearing that Galileo's discoveries undermined Scripture, summoned him to trial. In 1633, he was forced to renounce his findings under threat of torture and spent the rest of his life under house arrest. Yet, even confined, Galileo whispered his defiance, and yet it moves. His discoveries, though officially condemned, continued to inspire those who sought the truth. The mathematician's triumph. As Galileo suffered for his ideas, another genius worked in quiet persistence, Johannes Kepler. He pored over the meticulous observations of Tycho Brahe and saw patterns no one else had noticed. The planets did not move in perfect circles, as believed, but in ellipses. This discovery shattered ancient beliefs and led to his 3 laws of planetary motion, which explained planetary paths with mathematical precision. Kepler, too, faced hardships. He lived in a time of war and religious persecution, and his mother was accused of witchcraft. Despite these struggles, he pressed forward, driven by an unshakable belief in the power of reason and observation. The grand unification. Still, one question remained. Why did the planets move this way? The answer lay with Isaac Newton, a man who would reshape science itself. In Principia Mathematica, he unveiled the force that governed the cosmos, gravity. With his laws of motion, Newton demonstrated that the same force binding an apple to the Earth kept planets in their celestial paths. The Sun's gravity held the planets in orbit, proving once and for all that Copernicus, Galileo, and Kepler had been right. Newton's work brought heliocentrism from theory to certainty. He too faced opposition, but his discoveries were undeniable. Science had triumphed over dogma, and the universe had revealed its secrets to those who dared to seek them. A new age of understanding. With Newton's revelations, the debate was settled. Over the centuries, telescopes grew stronger, astronauts ventured beyond Earth, and space probes sent back images from the farthest reaches of the solar system. The heliocentric model was no longer just a theory, it was a fundamental truth, shaping our understanding of the universe. The struggles of Copernicus, Galileo, Kepler, and Newton were not in vain. Their ideas paved the way for the scientific age. The legacy of heliocentrism. The battle for the sun-centered cosmos was more than just a scientific dispute. It was a shift in the way humanity perceived itself. No longer the focal point of creation, Earth became one world among many in an infinite universe. But beyond astronomy, the fight for heliocentrism was a testament to human perseverance, the courage to challenge authority, the willingness to endure punishment, and the relentless pursuit of truth. The journey to heliocentrism was one of bravery, sacrifice, and resilience, proving that the pursuit of knowledge is an unstoppable force, always reaching toward the light.